Hi and welcome to Topic Busters from onmaths. Today we're looking at sectors, arcs and segments. No need to feel like you're partially going around in circles with this one. Enjoy! Hi and welcome to this episode of Topic Busters looking at sectors, arcs and segments. Now, the highest grade question is right at the end, and this whole thing is building up to that question. If you can answer that question, you've kind of understood the whole thing. So see this as a bunch of stepping stones with lower grade stuff. We start at grade 3, move on to grade 5 work, and then we do the grade 7 right at the end. But you need to understand everything to be able to answer that question. I hope you enjoy it. Thank you very much. Okay, so first things we need to work out is what the formula for circumference and area is, or are, I should say. So the circumference is pi times the diameter, or 2 pi r. Okay, the diameter is just 2 times the radius, so that's pretty obvious. So the circumference is pi times what the diameter is. Well, the diameter is 5 times 2, which is 10. Okay, because we're given a radius in this. And we can write that as 10 pi, or we can write that as, well, let's have a look. 10 times pi equals, and we can write that as 31.41. Well, let's round it to 2 decimal places, so 42 centimeters. And circumference is a distance. It basically means the distance around the circle. Okay, the formula for area is just pi r squared. Now be careful, that does not mean we double the radius, otherwise that would give us the circumference. When you square something, you times it by itself, as you probably know. So pi times the radius, which is 5 squared, which is 25 pi in terms of pi. Or if we're going to give an exact answer, 25 times pi, and it's 78.54, and this time it's centimeters squared because it's an area. So same thing for next one, but this time we can just use pi times the diameter because we're given the diameter in the question. And so that's either 25 pi or, well, we've already worked that out, haven't we? 78.54, this time meters because its circumference is a distance. And the area is pi r squared, so it's pi times, and that would be 12.5 squared because the radius is half the diameter. So pi times 12.5 squared, and it's 490.87, and that would be meters squared. Or you can leave it in terms of pi, so it would be, where is it? Let's just do that. 156.25 pi. Okay, last one. Now this time we imagine that we've got that bit of a circle. Imagine the circle is, and this is a dodgy circle, imagine the circle's all the way around. So, well, how much of that circle have we got? We've basically got a quarter of the circle. So let's get rid of that. So what we want to do is, for the circumference, we want to do it for the whole circle. So the formula would be pi times 6, because that 3, it would be a radius, right, if we drew the full circle. And then what we want to do is find a quarter of it. So I'm going to do it on the calculator. So, well, 6 divided by 4 is 1.5, so it'd be 1.5 pi, and then let's times that by pi, and you get 4.71, and that would be centimeters because circumference is a distance, and the area would be pi r squared, and so pi times r, which is 3 squared, and we're going to find a quarter of it because we've got a quarter of the circle. So pi times 3 squared times a quarter, and it's 7.07 centimeters squared, or in terms of pi it would be 2¼ pi. Okay, have a go. Okay, so for the first one, the circumference would be pi times the diameter, which is 7 times 2, so 14. So that would be 14 pi, and let's get my calculator out. So 14 times pi would be 43.98 meters. Okay, because it's distance, just meters. Area would be pi times r squared, so 7 squared. And I'm just going to give these as actual answers rather than in terms of pi from now on. So 153.94 meters squared. Okay, circumference for the next one. So it'd be pi times 13, because we're given the diameter. So pi times 13 is 40.84, and that would be centimeters. And the area would be pi times r, which is 6.5 squared. So pi times 6.5 squared be 132.73. And the circumference for the last one is going to be pi times the diameter, which would be 8, and then times a quarter. So pi times 8 times a quarter, which is just 2 pi, because 8 times a quarter is 2, and it would be 6.28, and that would be meters, and this should be centimeters squared. Let's just put that a unit in, and the area would be pi times r squared times a quarter. Let's just work that out, which is just the same as 4 pi, which is 12.57 meters squared. Okay, so in this question we're giving a part of a circle. We know that the radius is 5 centimeters, and we're given 31 degrees of it, and we're asked to find the arc length. Now the arc length is the circumference of the circle. It's basically this bit here, but it's not the circumference of the full circle, it's a bit of the circle, and a bit of the circumference is called the arc. So let's do that one first. So the arc would be, well, we first of all work out the circumference of the circle, which is pi times the diameter. So pi times, double 5 would be 10, because we're given the radius. And what we need to do is find out the fraction of the circle we have. Now, on the last question, we had a quarter of a circle, so we times it by a quarter. There's a really easy formula for this. We do the amount of degrees we've got, which is 31, and you put it over the total amount of degrees in the circle, which is 360. Now, the angle in the last question on the last slide was 90 degrees, so it would be 90 over 360, which cancels to a quarter. And then we just times it, and it's that simple. So I'll type that into my calculator. So I do 31 over 360, and then come off the fraction, times pi times 10. And I get the answer of 2.71 centimeters. And it's that simple. So the area of the sector, a sector is like a slice of pizza in the circle. That's what we call a sector. And it's the same thing, exactly the same formula. So it's 31 over 360, because that's how much of the circle we have, times by, but this time it's pi r squared, because we want the area of the full circle. So pi times 5 squared. So I type that into my calculator. 31 over 360, and then times by pi times 5 squared. And that gives me an answer of 6.76. And it would be centimeters squared, because it's an area. Now the perimeter, what we do is we go back to the arc length, and what we want to do is find the, let's write down the perimeter so we know what we're doing. So perimeter equals the arc length, which is the curved bit of the shape, plus the radius, because what we need to do is come down this way, because the perimeter is the total distance around the shape, and then we need to add another one of them, so we need to add another radius. Okay, so it's 2.71 plus the radius, which is 5, plus the radius again, which is 5. Now what we might want to do, because we've rounded this, we might want to type in 31 over 360 times pi times pi times 10 in our calculator again to get the exact answer, which was 2.705 blah blah blah, and then plus the 10, or plus the 5 plus the 5. So it's 12.71. Okay, and you see that actually, because we're adding 10, we don't need to worry about that. And so that's a perimeter, so that's in centimetres. So perimeter just means the whole distance around the shape, so we just need to add 2 radii to it. Okay, have a go. Okay, so to find the arc length, what we do is the fraction of the circle we've got, which is 23 over 360, times by pi d, well the diameter would be 20, so times by 20, because the radius is 10, we double it. And so let's bung that into the calculator, so 23 over 360 times by pi times by 20, and we get the answer of 4.01 meters. The area, the sector, if I can spell area, would be the same formula, so 23 over 360, the fraction of the circle we've got, but this time times by pi r squared, so times by pi times 10 squared. So 23 over 360 times by pi times by 100, or 10 squared, and that gives me 20.07 meters squared. And then finally the perimeter is going to be the 4.01 plus 10 plus 10, so it would be 24.01 meters. Okay, a lot of the stuff we've been doing so far in this video is building up to the green question at the bottom, which is the whole purpose of this video, and it all kind of fits together when we do that question. But there's a principle that we just need to look at first, and it's the idea of finding areas by finding 2 shapes and taking them away from each other. For this first question, what we want to do is find the big shape, then we need to find the littler shape, or the little shape, and then take them away from each other to find the bit that is actually shaded. Okay, so I'm going to call them the big sector. So big sector. I'm going to find out the area of it first. So the big sector is the area would be 21 over 360 times by pi r, which for that one is 10 squared. And I'm just going to work that out, but I'm going to leave it in terms of pi. So 21 over 360 times pi times 10 squared. And most calculators now just leave it in terms of pi for you. So 35 over 6 pi, or 35 pi over 6. Now we're going to do the small sector, or smaller sector. Okay, and I'm just showing the examiner which one I'm working out. Same formula, but the radius of the small sector is going to be 8. So I type that into the calculator, 21 over 360 times pi times 8 squared, and you could remove the times pi and then you can just have the 56 over 15, or 56 pi over 15 means the same thing. So the area of the shaded bit is going to be the big sector take away the small sector. So it's going to be 35 over 6 pi take away 56 over 15 pi. I'm just going to type that into my calculator. So 35 over 6 pi take away 56 over 15 pi, and I get 21 over 10 pi, which equals 6.5, 6.60, because the next one's a 9 and the next one's a 7, and that would be meters squared. Okay, now this next one you might think, well hang on, that triangle we don't have a height for. Well, there's actually a formula that you need for this next one, and the formula you need is the trigonometric area formula, and it is half AB sine C. Now you might think, well, what is A, B and C? Well, with trigonometry, with sine and cosine rule, we label the angle for this one C, and the opposite length is C, a lowercase c, and then the other lengths are A and B. Now we're not using C and we're not using angle A or angle B, but you can see that we need the two lengths next to the angle, and then we can use this formula, and we have that in this question. So we're going to do half times A, which I'm going to call 6, doesn't matter which you call A, whether it's 6 or 7, B 7 times sine, and we always sine, cos or tan an angle, so this is going to be 32. I'm just going to type that into the calculator, so half times 6 times 7 times sine 32, and it says 11.13 to 2 decimal places, and that is an area, so it's meters squared. Okay, so we bring this all together now. Now here we have something called a segment. Now a segment is like a sector, but instead of pizza slices, it's like you've got the pizza and just drawn a knife across it. So it's from a chord, and it's that little shaded bit at the top of this question. Okay. Now to find the area of a segment, you've got to find the area of the sector, then you've got to find the area of the triangle and take them away, like we did on the first question. So we're bringing all our knowledge together here. So I'm going to start off to find the area of the sector. Okay. Now this sector is the full shape. Okay, so to do that we do 22 over 360, which is the fraction of the circle we've got. We times it by pi r squared, which is the area of the full circle. So the radius is 5 squared. Okay, let's do that on the calculator. 22 over 360 times pi times 5 squared. And again, I'm going to leave my answer in terms of pi so I have some accuracy, because I know that I'm going to do something else with this later on. So that's the sector sorted. Now we've got to work out the area of the triangle. Now we use what we've learnt, the formula for the area. Now you might say, well hang on, we've only got A, we don't have B. Well, in a circle the radius is always the same. So if the right hand side is 5 meters, the left hand side is going to be 5 meters. So let's have a look. So the area is going to be half times A, which is 5, times B, which is 5, times sine C, which is 22. Put that into my calculator. Half times 5 times sine 22, and it gives me the answer of 4.682 blah blah blah. Now I'm going to keep that into my calculator because we're going to work out the area by doing the sector, which is the full shape, take away the triangle, which is the bit we want to get rid of. Now I've kept that in my calculator because what I'm going to do now is, with that in my calculator, the 4.68 blah blah blah, I'm going to do 55 as a fraction over 36 pi, and then I'm going to type in take away answer, and that will keep the accuracy for me for the 4.682. Now if you don't know how to do that in a calculator, or you don't have a calculator that can do that, just write down as many decimal places as you can, probably about 6 or 7 will do. When I press equals, it says that it's going to be 0.12 meters squared, so not very much. But then again, it's 5 meters and 22 degrees is not very big, so we'd expect it to be quite small. Okay, have a go. Okay, so to work out this shaded area, we want to work out the big sector, and we want to take away the small sector. Now it's probably easier if we do this separately, but I'm just going to save time by doing it all in one go. So we're going to do 19 over 360 times pi times 5 squared. Okay, for the big sector. we're going to take away, again, 19 over 360 times pi times, and this time 4 squared. So I'm going to put that into my calculator. So brackets 19 over 360 times pi times 5 squared, close brackets, take away, open brackets, 19 over 360 times pi times 4 squared. And normally with long calculations like this, I just check it and all looks good. Press equals, and it gives me the answer of 1.49, and it would be meters squared. Okay, for this one, we want to work out the area, okay, which is half times A, which I'm going to call 8, times B, which I'm going to call 9, times sine 24. Okay, so it's 0.5 times 8 times 9 times sine 24. Again, just quickly check it, it looks good. And that's 14.64, and this is still meters squared. Okay, so to find out shaded, it's going to be sector, take away, where's it, triangle. Okay, so the sector will be 32 over 360 times pi times r squared, which is 3 squared. I'm going to take away the triangle, which is half times A, which is 3, times B, which is 3, times sine 32. Okay, so open bracket, 32 over 360 times pi times 3 squared, close bracket, take away, open bracket, half times 3 times 3 times sine 32, and then close bracket. Let's just check that all looks good. It does all look good, and I don't recommend you do it all in one calculation, because if you make a mistake, you end up getting completely the wrong answer and the examiner can't give you any marks. So try and work out these things separately, but I've saved a little bit of time doing it this way. Okay, and I get 0.1286 blah blah blah, which will round to 2 decimal places is 0.13 meters squared. Thank you very much for watching this Topic Busters. If you enjoyed this one and want to see more, please look at our YouTube account. Just type in onmaths on YouTube and we come up. Otherwise, go to the website onmaths.com and you can have a go at all of our predictions, Topic Busters, demon questions, mini mocks and countless other things. Thank you very much.